the probability of B will be equals to of B naught minus 1.
So it's going to be probability of B plus the probability of B naught are complementary events. They give us 1.
Yeah.
And then it means the probability of B is going to be given by 1 minus the probability of B naught. So we have probability of B, which is going to be given by 1 minus 3 of 8. And then if you say you have 3 of 8 things, then you're going to be left with 5 of 8 things. Okay, let's try that. So we're going to have 1 minus 3 of 8. Then you're going to be left with 5 of the 8 things. So for this one here, you are going to get 2 marks. And then it's going to be 1:2. All right, let's try number B then. How would you get number B? Now a hint, we are going to say number B, the probability of A or B is given by this formula. It says probability of A plus the probability of B minus the probability of A and and B. So look at this here. Again, they told us what is the probability of A or B. This is one again.
Yes.
And then they told us what is the probability of A is this one here. And then we just got what is the probability of B. So how would you get this? How would you get this one then?
I'll substitute first and get mistake.
Okay, let's substitute. You are going to say
5 all over 7.
You have 5 of 7 things, yeah.
We're calling 2 all over 5.
It's 2 all over 5.
Plus 5 all over 8. 5 all over 8.
All over 8, yeah. Minus
probability of A and B.
And B. Okay, sure. What do we
and
do from here?
I'll add probability of A plus probability of B.
Okay, if you add these two, you are going to get 2 of 5 things.
Yes.
Plus 5 of 8 things.
Yes.
And then it gives you 41
all over 40.
Okay, minus probability of
A and B.
A and B. And then this is going to be 5 all over 7. Okay, what do you do from here then?
And then I'll take 41 over 40, transpose it to the other side.
So you want to take, okay, here you have 5 of 7. I would propose, which let's take this one. I agree this one here is negative. Can you see this one here?
Yes.
Yeah, I'm going to take this one. I'm saying let's take this one. I think it should be better if we do it that way. So if we take this one to this other side here, and then we take this one to this other side, like it is positive. When it gets this side, it's going to become what?
Negative.
Yeah, so you have the probability. Yeah.
Nah, I thought go for Jara, so.
You wanted to take this one.
I
no,
thought it was impossible.
Eh?
I thought it was impossible to take the other one to that side and then again get a like I apply.
No, I agree there's a minus. For the fact that there's a minus, then you can transpose. You can if it was a multiplication, then it was going to be another story. So we have the probability of A and B, which is going to be given as 41 all over 40 again. Minus 5 all over 7.
All over, yes.
And then we get 41 all over 40 minus 5 of 7. And then we get what?
We get 87 all over 2. 87 over 208.
208. Yeah, you can put this and then check which what is it in decimals. In decimals, then you get 0,310. Okay, 0,31. Okay. All right. Yeah, and then you'll also get you'll get 1 mark for substitution here. And then you'll get 1 mark for simplification, and then you'll get 1 mark for the final answer. Whether you leave it as a fraction or you leave it as a decimal, it doesn't matter. Ne?
Are not.
They are not. Ne?
Yes.
So we're going to say which this they are not. Okay, this is going to be 8.1.2 again. So they are
Yes.
not.
Yes.
Okay, why they are not mutually exclusive?
Because we have an event whereby we have both A and B.
Yeah, we do have A and B. If you check here, there's a probability. I get the probability, like they are not mutually exclusive again.
Yes.
And then the reason why they are not mutually exclusive is because probability of A and B is not equal to 0. So if the probability of A and B is equal to 0, then they are mutually exclusive. But because the probability of A, I agree they said we should give a reason for our answer. Yeah. So we say they are not.
Yes.
That's one. Yeah? And then giving a reason for your answer, motivate your answer. Probability of A and B is not equal to 0. Then you get another mark for that.
Yes.
Venn diagrams again.
Yeah.
Yeah, on your Venn diagrams, remember, here's what you have here. You have A only, like here. This one, it's A only. This part here, excluding this part. Like, if I go like this here, if I go like this here, this thing here represents the probability of A again. But now, if I take this part out, if I just take this part out here, this is going to be A only. So this part represents A only. And then what does this part represent? This thing here, what does this part represent here?
B only.
It's going to represent B only again. And then, okay, now what does this shaded part represent here? What does the shaded part represent? It represents the intersection between A and B again. So we say which is the probability of A and B. You get that again? Okay, now here, if we take everything here, this is the probability of A or B. This part here, this whole thing here, it represents the probability of A or B. Excluding the outside part. Again, we still have the outside part. Can you see that again? So what does the outside part represent? What does the outside part represent?
Not A, not B.
Yeah, so it represents the probability of A or B not. So we have this representing the probability of A or not B. Does that make sense?
Yes.
Yes.
Okay, let's go to number 8.2.3. What does this represent here? What does this part represent here?
A only.
It represents A only.
Which one?
Yes.
This part here, this one here,
It's A only.
it's A only. What does this part represent here?
B only.
B only.
Yeah, so what does this two thing represents then? What will you say this thing represents, both of them?
A only and B only.
Yeah, so they represent A only and B only.
Yes.
I will still put them. And then they're giving us 1 mark for these things. 1 mark for this, 1 mark for this, and then 1 mark for this. Okay, let's go to this one here then. Which diagram represents mutually exclusive events? Which of the diagrams represents mutually exclusive events? 8.1.2, 8.2.2, and or 8.2.3. Which one represents mutually exclusive events?
The last diagram.
The last
The
diagram.
last
again.
one.
Yeah, why the last diagram?
Yes. Because we don't have a situation whereby 2 events are happening at the same time.
So we don't have an end again. Yeah, so we'll say
Yes.
here 8.2.3 is the one which represents, and then we get 4 marks for this thing here. And then a survey was done among 80 learners. So the total sample space here, we'll write it outside here with, okay, our SN, the total number of learners that we have, they're 18. Okay. And then they say on their favorite sports. So the results are shown below. So we have rugby, we have volleyball. So we'll come and represent them here. Say, okay, this one here, it's R, it's rugby again. And then after that, we are going to have volleyball. We'll represent it with V. So we have, let's use blue here for volleyball. Okay, for volleyball, we have V. And then we have green one, it's chairs. So we have 3. So we have R, we have V, and then we have C as they are represented here. And then they say 14 learners.
Yes.
14 learners like rugby and volleyball, but not chess. So they like rugby, and volleyball, but not chess. And then 12 learners like rugby and chess, but not volleyball. 15 learners like volleyball and chess, but not rugby. Okay? And then they have X learners, which like all 3 sports. So where do we get all 3 sports here? 3 sports, we get it where we have blue, green, and red. All of them, they're intersecting. Can you see that again here?
Yes.
Yeah, so we'll come and say, okay, here, this is going to be our X. So we'll come and write this as X here. In the middle, we have X. This is people who are, who like all 3 sports. And then they say 3 learners didn't like any sport. So the people who didn't like any sports here, we're going to put them outside here. There are 3, those ones. I will still find them.
Yes.
All right, now let's go on and fill in some of the information then. We're going to start from the bottom and then we're going to go up. 15 learners, they like volleyball and chess. So we're going to say volleyball and chess. Right? Volleyball and chess is represented by green and blue, but not rugby. You see that one again? So we are not going to go to the red one. So 15 is just going to be the space here, excluding the red. Actually, they don't write, they are not inside the red part. You see that again? So they are only inside the blue and the white and the green. Okay, they say 12 learners like rugby and chess again. So rugby and chess. So you have rugby and chess. And then not volleyball. So volleyball is blue again. So we can't go to the blue part. So how many learners should we put here? We're going to put 12 here. Is it still fine? Okay, and then they say 14 learners like rugby and volleyball again. Rugby and volleyball, it's blue and red again. And then blue and red part, not green. We don't want green. So we're not going to go inside the green part. So how many learners are like that? It's 14. Okay. And then they say, okay, but now we have 5 learners who like chess only. You see this part again? Chess only, chess only, chess only is like, when it says chess only, we are not going to include the red. We're not also to include the blue. So how many learners like chess only? We put 5 here. We can
5.
All right, sure. And then they say 42 learners like volleyball. Here you should be careful here. They like volleyball. Volleyball, it means everything which is blue. I think they didn't say volleyball only. Do you see the difference between here? They were specific chess only. Chess only is like exclude the red and the blue. Here they're saying volleyball only. They're saying 42 learners like volleyball. They didn't say volleyball only. They just said volleyball. So because they said volleyball, it means which the way to get this, we are going to say 42 is this whole blue thing here. Now, if I want to get volleyball only, I am going to say that it's 42 minus the people that I've already counted, minus the 15 that I've already counted, minus the X. Yeah, so if I say that I am going to get like this, it's going to be 42. 42 is going to be everything which is blue again. Now, inside the blue, you've already counted 14. You see this 14 is inside the blue again. So you minus the 14. You minus the X. You also minus the 15. And then it's going to give you volleyball only, people who like volleyball only. How many people like volleyball only? Is what? It's 13 minus X. It's not 13. It's going to be 13 minus X. Are we still fine, guys, there?
Yes.
All right, let's go to this one. I want you to differentiate between rugby only and rugby. They say 52 learners like rugby. So if they say 52 like rugby, are they talking about rugby only, or they are talking about the whole red thing here?
Whole red thing.
They're talking about the whole red again. So if they're talking about the whole red, it means you're going to say 52 minus part of the things that are still part of the red. What are the things that are part of the red here? It's minus 14 again, minus 12, minus X again. And then if you say this, what you get? Is 26 minus what? Minus X. So rugby only is going to be 26 minus X. Are we still together there? And then for you doing something like this, they're going to give you 5 marks. Now, how would you get your 5 marks? You're going to get your 5 marks by putting the intersection here, and then rugby only, and then or volleyball only, rugby only, and then we have chess only, and then we have not going. Okay. So we're able to get the Venn diagram in order. Now, after that we got the Venn diagram in order, they say 9.2 show us which x is going to be equal to 8. Ne? Now, how do you show them which x is going to be 8? 9.2. You're simply going to do it this way. You're going to add this one plus 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 this one. And then all these things, they're supposed to give you what? 8. So we're going to say 26 minus x again, plus 14 plus 13 minus x again, plus x plus 12 plus 15 again, plus 5 plus 3. Ne? All these things that are supposed to give us what? 8. And then here you'll see which we have like terms again. Let's check some of the like terms that we have. So like terms which we have, this one is positive, this one is negative. They're going to cancel each other out again. And then you are going to be left with, if you add these things here, we're going to add them up. So we have 26 plus 14 again, plus 13. Okay, let's try that. Let's do it. So we're going to have, we have 26 again, plus 14, plus 14, plus 13, plus 12, plus 15. What else do we have?
5.
Plus 5.
5.
I said 16.
15,
I made a mistake.
Mr. No.
Oh, it's 15 plus 5, and then plus
3.
Plus 3.
Yeah.
Yes.
Okay, then we get equals to again. And then we get 88. Ne? So I'm going to say minus x plus 88 is going to be equal to 8. Ne? And then you take this one to this other side. It says minus x is going to be equal to 80 minus 88 again. And then obviously you're going to have minus x, which is going to be minus 8 again. And then divide both sides by minus 1, divide both sides by minus 1. It says which x is going to be equal to what? 8. So we'll give you 1 mark for simplification, 1 mark for substitution, 1 mark for simplification, and then that's going to be your 2 marks. And then they say here, even if you couldn't get which your x is 8, when you go to this question now, you're going to put 8 here again. So if you come and put 8 here, this here it's 8. Okay, we'll come and put with this one here, it's 8. If this one is 8, then we have 26 minus 8. What is going to be 26 minus 8? 18. Then you're going to erase this one and then put 18 now. So you have 18 here. And then 13 minus 8, what do you get? You
5.
get 5. And then we'll come and put with this one here is 5. And then the first question that they're asking us here, 9.3, they say, how many learners like Rappi only? Are only like how many learners like Rappi only then?
18.
It's 18, yeah. We'll come and put with this one here, it's going to be 18. And then they say, calculate the probability that a learner chooses at random. Calculate the probability that a learner chosen randomly likes at least 2 types of sports. At least 2, again. 2 is the minimum. So if they say, Kuchi, they want 2 as the minimum, this is what we're going to do. 2 as the minimum is this one here. It's this one plus this one plus this one plus this one. Again, they say at least 2 again. At least 2, you are only going to include, again, if I choose 18, 18 is Rappi only, so it's 1. 5 here, it's volleyball only, so I'm not going to choose that one. 5 here, it's also chess only again. 3, it's not anything again. So when they want at least 1, if they want at least 1, so how do you get at least 1? You're going to say the probability of at least, or they said at least 2 again. So we'll say the probability of at least 2 is going to be given by 14 plus 8 plus 12 plus 15. This is going to be all over the sample space. I get a sample space here, it's 18. Yeah, so you take this, there are 2 here. These people, they like Rappi and volleyball. these people here, they like rugby and chess. Okay? These people like volleyball and chess. These people, they like all three. So at least we can include even people that like all three. Then if you put this in your calculator, what do you get?
49/8.
It's 49 all over what? All over 8. And then you'll get 1, 2, 3.